Hello, welcome back again. Okay, as I informed you in the previous video, here I will explain to you some design guidance for photorelays and show you the actual operation with a Toshiba emulation board. I already explained on the previous video that space saving, freedom from acoustic noise, high reliability, long lifetime, and low power consumptions are the main advantages of photorelays. When you decide to use a photorelay, first you have to pay attention on the IF design. Consider the LED operation time and operation temperature. And next, overcurrent and overvoltage considerations on the output side. For IF design consideration, in order to turn the photorelay on, the input current IF should be designed to be higher than the trigger IFT. So based on the maximum trigger current specified in our data sheets, you need to also consider other factors like LED declaration rate, which you can drive from LED projected light output declaration data, IFTTA characteristics, which you can also drive it from our datasheets. And you also need to consider drive factor, which is caused by power supply fluctuations and tolerance level. So for example, if IFT max is specified 3 mA at our datasheet, and we want to use it at 85 degree with a lifetime of 100,000 hours, so design IF on should be 3 mA, which is our IFT max, times 1.43, which is our LED declaration rate, times 1.5, which is IFTTA characteristics at 85 degree. So our set IF should be more than 6.53 mA in this case. Let's look in more detail at design considerations. Considering LED operation time of IF design. In design failure example 1, the LED trigger current in the datasheet is specified 3 mA max at an ambient temperature of 25 degree. So Mr. A set the design IF at 3 mA and the prototype set worked fine in the lab. However, it didn't work after 1000 hours ongoing test. So light output actually dropped by 10% at 1000 hours. Therefore, IFT has to be compensated by 10% for the operation. It didn't work at this case because IF was 3 mA instead of 3.3 mA. Considering the LED operation temperature of IF design. LED trigger current in the datasheet is 1 mA typical at an ambient temperature. Mr. A set the design IF at 1 mA. The prototype set worked fine when tested in the lab. However, the set did not work properly at the production. IFT increases with higher temperatures. So according to our IFT temperature characteristic curve on our datasheet, the design IF of 1 mA actually became less than IFT required to turn on the part at 60 degree. Therefore, the photorelay did not turn on at IF 1 mA. Next is the overvoltage and overcurrent on the output side. There are cases in the load power supply whereby the induced impulse noise of the power line overlaps with the ESD surge, causing damage to the photorelay output chip. In case of short failure, photorelay is on even when there is no input in LED. In case of open failure, photorelay is not on even there is an input in the LED side. A countermeasure is to add a varistor. Varistor typically acts like a condenser, but with high currents from the overvoltage, it acts like a resistor to draw away the short circuit current, thereby protecting the circuit. So please choose a varistor with limiting voltage, not more than off-state terminal voltage of the photorelay. These are some examples of actual design considerations, and you can find more and more information from Toshiba's photorelay ebook, which you can download from Toshiba's website. And Toshiba also offers an emulation board with the highest current rate 5 ampere DIP package photorelay, mounted on the same pin figure of a mechanical relay. Let's check together how it works. This one is 5 ampere on-state current and 60 volt off-state voltage photorelay TLP3547 in a DIP 8-pin package. And this is 3.3 ampere on-state current and 60 volt off-state voltage photorelay TLP3107 in a SOP 6-pin package. Input side of the coil is between pin 1 and 2, and output side is pin 3 and 4. You can directly replace your mechanical relay with this evaluation board to test your design. You can see how it works here. When examining the replacement of mechanical relay, this evaluation board is effective for shortening the time of set development, as it has same pin arrangement, so you don't need to change the board. You can apply this for free on Toshiba's website. So please try it now.